The Texas power grid operates separately from the rest of the United States. While most American states share interconnected grids that can exchange power across state lines, Texas manages an almost independent system. Winter Storm Uri in February 2021 tested what that structure means when extreme weather arrives. Texas electricity is managed by ERCOT, the Electric Reliability Council of Texas. ERCOT operates what's essentially a separate alternating current grid with limited connections to neighboring systems. Two direct current ties link Texas to other grids: an 820-megawatt connection to the Southwest Power Pool in the Eastern Interconnection and a 400-megawatt connection to Mexico. Combined, these ties represent about 1,220 megawatts of transfer capability, roughly 1.5% of Texas's typical peak demand of around 70 gigawatts. That limited import capability means ERCOT has to balance electricity supply and demand in real time, primarily using generation resources located within Texas itself. When demand surges or generation drops, operators can't simply call on large amounts of power from neighboring grids. The system has to respond with what's available inside its own boundaries, adjust demand through controlled load shedding, or accept the risk of uncontrolled collapse. In mid-February 2021, an Arctic cold front moved across Texas. Temperatures dropped to levels the state rarely experiences. Winter Storm Uri brought freezing conditions across the entire ERCOT region. More than 4.5 million people lost power. Some areas went without electricity for several days, while outdoor temperatures stayed below freezing. Texas health authorities officially recorded 246 deaths from the storm. Across the south-central region, unplanned generation outages reached 65,622 megawatts at their peak. Inside Texas, ERCOT operators faced cascading equipment failures. They implemented approximately 20,000 megawatts of controlled load shedding, intentionally cutting power to some areas to keep system frequency stable and prevent the entire grid from collapsing into uncontrolled blackout. Controlled shedding is a deliberate operational decision. Uncontrolled collapse means operators lose the system-wide balance they are trying to preserve. The February 2021 failures weren't limited to one type of power plant or one fuel source. According to the Federal Energy Regulatory Commission's investigation, freezing issues were the largest single category, accounting for 44.2% of total outage and derate megawatt events. Fuel supply problems contributed another 31.4%. When broken down by generation type, natural gas-fired units represented 58% of all affected generating units. Wind accounted for 27%, coal 6%, and solar 2%. Natural gas plants experienced both equipment freezing and fuel supply disruptions. Wellheads, gathering lines, and processing facilities froze. At the same time, sensing lines and instrumentation at the plants themselves failed in the cold. Wind turbines iced over. A unit at the South Texas Project nuclear plant tripped offline due to frozen sensing lines. Coal plants dealt with frozen equipment and fuel handling problems. The core issue wasn't that Texas equipment couldn't work in cold weather. Similar generation technologies operate reliably in much colder climates. The difference is winterization. Before 2021, Texas had no comprehensive mandatory winterization standards. Equipment across all fuel types was vulnerable to extreme cold because protection measures were voluntary, inconsistent, or absent. The natural gas system presented a specific interdependency problem. Power plants need natural gas as fuel. Natural gas infrastructure needs electricity to run compressors, processing equipment, and safety systems. When both systems started failing simultaneously during Uri, each failure made the other worse. Gas supply problems reduced power generation. Power outages disrupted gas production and delivery. the problems compounded in both directions. After February 2021, Texas moved quickly on regulatory changes. The state legislature passed Senate Bill 3 in 2021, mandating weatherization of power generation facilities and natural gas infrastructure. The Texas Public Utility Commission adopted comprehensive winterization standards under Rule 25.55, formerly called Weather Emergency Preparedness. The rule requires protection from freezing, documented winterization procedures, annual preparedness reports, and regular inspections. Generation facilities faced a December 1, 2022 deadline for compliance. The rule includes enforcement authority and penalties for facilities that don't meet standards. At the federal level, the Federal Energy Regulatory Commission directed the North American Electric Reliability Corporation to develop extreme cold weather reliability standards. FERC approved those standards in September 2023 under Order Number 896. Winterization includes heat tracing for pipes and instrumentation, electric heating elements that prevent freezing. It includes insulation for equipment housings, enclosures to protect critical components from wind and precipitation, fuel supply weatherization at natural gas facilities, and updated cold weather operating procedures. The measures are designed to keep equipment functional when temperatures drop and stay below freezing for extended periods. Compliance means facilities document what protection measures they've installed, test those measures before winter, report their readiness annually, and allow inspections to verify that the equipment actually works as documented. The standards don't just require facilities to have winterization plans on paper. They require physical protection measures, operational testing, and accountability for failures. In late January 2026, another winter storm moved through Texas. Winter Storm Fern brought freezing temperatures and winter precipitation across the ERCOT region from January 23rd through the 26th. This time, the grid remained stable. According to ERCOT's operational data, generation stayed online and reserve margins held. There were no widespread power interruptions. Winter Storm Fern provided a documented operational test of the post-2021 winterization measures under actual winter conditions. The system performed as intended during that event. But one successful test doesn't eliminate all risk. It doesn't prove the grid can handle every possible extreme weather scenario. It doesn't mean every component is now permanently protected against all future cold events. And it doesn't prove that winterization alone was the only factor that made the difference. Other conditions during Fern may have been different from Uri in ways that also mattered. What the January 2026 event does show is that the grid handled freezing conditions without widespread failures after the mandatory winterization standards were implemented. That's a meaningful operational result. It's not a proof of complete reliability under all future conditions. The Texas power grid continues to operate largely independently. That structure gives Texas control over its own grid operations, its own market rules, and its own regulatory decisions. It also means that when extreme weather arrives, Texas manages the response primarily with the resources available within its own boundaries. The limited interconnection capacity means ERCOT can't rely on large-scale power imports to cover major generation shortfalls. The state implemented winterization requirements after February 2021. Those measures were tested under real winter conditions in January 2026, and the system held. Whether that preparation is sufficient for every future extreme event remains an open question. The answer depends on continued compliance with the standards, ongoing inspections to verify that protection measures are maintained, and whether the next storm pushes beyond the temperature and duration parameters the new rules were designed to handle. The February 2021 storm showed what happens when a largely independent grid faces extreme weather without mandatory protection standards in place. The work since then has changed the regulatory framework and added physical safeguards. The grid's resilience going forward will be defined by whether those standards are maintained and whether they prove adequate when the next extreme event arrives.